wanted to share an announcement that highlights a major step toward building a trusted global market for low-emission ammonia. Envision Energy has joined the pilot phase of the Ammonia Energy Association certification system, which is designed to standardize how ammonia's environmental impact is measured and communicated. The system allows companies across the value chain, producers, traders, and buyers, to verify key attributes such as carbon footprint and origin using independently audited data. This is critical because without standardization, claims about green or low carbon ammonia can be inconsistent or misleading. A central feature of this system is a digital registry operated by MIQ, which ensures transparency and traceability across the entire supply chain, from production to final use. Ultimately, this initiative aims to create trust in global ammonia markets and accelerate the adoption of cleaner fuels. The certification system is built on several key principles to ensure credibility and flexibility. First, it is technology neutral, meaning it does not favor one production method over another. Whether ammonia is produced using fossil fuels, renewables, or hybrid methods, it can still be evaluated under the same framework. Second, the system emphasizes real measured emissions rather than estimates. This ensures accuracy and reduces the risk of overstating environmental benefits. It also adopts a well-to-gate boundary, meaning emissions are tracked from resource extraction all the way to ammonia production. Another important feature is that certificates are tradable, allowing environmental attributes to move across markets. Finally, independent audits ensure that all claims are verified, building trust among stakeholders and regulators. Gray ammonia is the traditional form of ammonia production and remains the most widely used today. It is typically produced using fossil fuels such as natural gas or coal through processes like steam methane reforming. The major drawback of gray ammonia is that it releases significant amounts of carbon dioxide into the atmosphere. There is no carbon capture involved, making it one of the more carbon-intensive industrial processes. Despite its environmental impact, gray ammonia still dominates the market due to its lower cost and established infrastructure. However, as global decarbonization efforts intensify, its role is expected to decline over time. Blue ammonia builds on the same fossil-based production process as gray ammonia, but adds carbon capture and storage technologies. These systems are designed to capture a significant portion of the carbon dioxide emissions before they are released into the atmosphere. While this reduces emissions, the effectiveness of blue ammonia depends heavily on how much carbon is actually captured and how well it is stored. Incomplete capture or leakage can significantly reduce its environmental benefits. Because of this, blue ammonia is often seen as a transitional solution, helping industries reduce emissions while renewable alternatives like green ammonia scale up. Green ammonia is produced using renewable energy sources such as wind or solar power. Instead of relying on fossil fuels, it uses electrolysis to produce hydrogen, which is then combined with nitrogen to form ammonia. There are two main approaches. Grid-connected systems draw electricity from the grid, which may include a mix of renewable and fossil energy. Because of this, emissions can vary depending on how clean the grid is at any given time. Off-grid systems, on the other hand, rely entirely on dedicated renewable sources. This makes them more consistent in delivering near-zero emission ammonia. There are benefits and challenges to both grid and non-grid approaches. For example, green ammonia can help grids adopt more green capacity as it can help with curtailment and grid balancing issues. This certification structure will help make the environmental benefit of green ammonia clear to stakeholders. Not all blue ammonia is created equal. True blue ammonia involves high carbon capture rates and rigorous monitoring of emissions throughout the process. It also accounts for upstream emissions, such as methane leakage from natural gas extraction. However, some projects claim to be blue without effectively capturing emissions or fully accounting for life cycle impacts. These are often referred to as fake blue. The AEA certification system addresses this issue by requiring independently verified data and full life cycle accounting, helping distinguish genuinely low emission ammonia from misleading claims. Similar concerns exist for green ammonia. Skeptics will question whether the ammonia is truly green and powered entirely by renewable energy sources. The chemical is identical regardless of the process. How could you tell if some producers rely on grid electricity that includes fossil fuels while still labeling their product as green? Others may use accounting mechanisms that double count renewable energy credits. The certification system helps prevent these issues by verifying the actual energy sources used in production and ensuring that environmental claims are accurate and transparent. The certification system uses three different chain of custody models to track ammonia across the supply chain. The segregated model provides the highest level of traceability by keeping certified ammonia physically separate throughout the supply chain. However, this approach can be complex and costly to maintain. Mass balance offers a more flexible alternative. It allows certified and non-certified ammonia to be mixed, while still tracking the proportion of certified product through accounting systems. Finally, the book and claim model separates the environmental attributes from the physical product. This allows certificates to be traded independently, making it the most scalable option for global markets. Each model balances traceability, cost, and scalability differently, depending on the needs of the market. The broader impact of this certification system is significant. By creating a standardized and trusted framework, it enables the growth of a global market for certified low-emission ammonia. Certification lowers friction, green ammonia becomes easier to market, purchase, and trade. This helps industries confidently adopt ammonia as a cleaner fuel or energy carrier, supporting global decarbonization efforts. Every ton of green ammonia used as fuel offsets about 6 barrels of oil. The carbon dioxide savings are immense. Ultimately, this system is not just about certification, it's about accelerating the transition to a low carbon economy by making sustainability measurable, verifiable, and tradable.